This is the University of Washington's Math 120 pre-calculus course. We're looking at the 6th question from the winter 2016 final exam. This question asks us to consider a goblin, a ghoul, and a zombie on a coordinate system. The goblin, we're given his initial position and his position at t equals 5. And we're asked to model his motion parametrically. In other words, write parametric equations to model his motion. The ghoul, we're giving slightly different information. We're giving the ghoul's initial position, and we're given the direction that the ghoul is walking toward, and we're given the speed that the ghoul is walking. So here we're given specifically at this time, the goblin is at this point. Here we don't have the information quite in that form. And the zombie is just stationary at the origin. The question asks us to do 3 things: model the goblin's motion parametrically, model the ghoul's motion parametrically, and finally, at t equals 1.5, find whether the goblin or the ghoul is closer to the zombie. In other words, whether the goblin or the ghoul is closer to the origin. And as always in this Collingwood pre-calculus course, we'll assume that this motion, or we are told to assume, that this motion is linear motion. They're moving in straight lines, and they're moving at constant speeds. So if you haven't already, go ahead and pause the video now and see whether you can make sense of the goblin and the ghoul's motion on your own. Let's look at the goblin first and draw a picture that doesn't involve the ghoul at all for the time being. We have a coordinate system. We have that initially the goblin is at -4, 2. And at the end of the day, or rather at t equals 5, the goblin is at 5, -3. So it looks like the goblin's path. I'm going to use b of t for the goblin and h of t for the ghoul. So I'm writing some function. B of t. And I want to represent the goblin's x position as a function of t and the goblin's y position as a function of t. So let me focus for a second on the x coordinate. When t equals 0, the x coordinate is -4. When t equals 5, the x coordinate is 5. I'm going to have something linear here. It's going to be something like at plus k. This -4 will work nicely for me because I know that this term will fall away when I plug in t equals 0. Now, when I plug in t equals 5, I need to put something here to make this work out. This behaves nicely. When t equals 0, this is -4, and when t equals 5, this is 5. I'll do something similar for the y-coordinate. When t equals 0, this will be the y-coordinate, and when t equals 5, does this work? When t equals 0, the y-coordinate is 2, which I like. And when t equals 5, the y-coordinate is -3, which I also like. Great. So here's our solution for part A. This is the goblin's position. Now, how about the ghoul? I'll just add the ghoul's data onto the same picture. The ghoul starts at 7, 3.2 and walks towards -5, 1. And walks at a speed of 4 units per second. Okay, so what I'd like to do is just compute the time that's associated with this -5, 1, and then use the exact same method that I did before with the goblin. So we know that the ghoul walks at 4 units per second. let's just compute this distance and find how long it takes for the ghoul to travel that distance. So the difference in y values from here to here is 2.2. And the difference in x values is 12. So the ghoul's distance traveled, I'm going to grab a calculator. This works out quite neatly. The ghoul's distance covered there is 12.2. So how long does it take the ghoul to travel that far? Well, the ghoul is traveling at 4 units per second. So what is 12.2 over 4? Well, it's 6.1 over 2. It's 3.05. Okay, so I've now converted the information that we were given about the ghoul into the same sort of information that we were given about the goblin. And now, given the information in this form, I can write the ghoul's parametric equations quite directly. I'll use h here. The x coordinate as a function of t, well, at t equals 0, the x coordinate is 7. And what I want to do here is this. Now, when I plug in t equals 0, I get 7. And when I plug in t equals, oops, not 3.2, I meant 3.05. At t equals 3.05, these will cancel, and the x coordinate will be -5. Now I'll do the same sort of thing for the y coordinate. At t equals 0, the y coordinate is 3.2. And now I want the y coordinate to decrease by 2.2. This should behave nicely. Now when t equals 0, I get a y coordinate of 3.2, and when t equals 3.05, I get a y coordinate of 1. So these are solutions to parts A and B. We have the goblin's position modeled parametrically, the ghoul's position modeled parametrically. The last part of the question simply asks us to say, at t equals 1.5, who is closer to the zombie? Who is closer to the origin? The zombie stands right on the origin. So let's just see what the points in question are. So I've computed the goblin's position at 1.5 and the ghoul's position at 1.5. I just want to look at my picture and see whether these numbers seem reasonable to me. The goblin was starting at -4, 2, and walking towards here. This can't be right. The x coordinate seems believable, but the y coordinate is certainly wrong. Okay. I can see that it's wrong because this 3.5 is not even in between the two y coordinates in question. So why did my y coordinate come out wrong? Okay, not so bad. In particular, I computed this 3.5 by plugging in by plugging in t equals 1.5 into here, but I messed up on a sign. So this should not actually be 3.5, it should actually be 0.5. Okay, better. I am now willing to believe these numbers quite a bit more. In particular, -1.3 is a little closer to -4 than it is to 5, and 0.5 is a little closer to 2 than it is to -3. So we're 1.5 seconds into our 5-second journey, and our x and y coordinates are still closer to the beginning x and y coordinates than the final x and y coordinates. So I have enough of an intuitive trust for this that I'm willing to move forward. With this, let's see, the ghoul started over here at 7, 3.2, and then traveled to -5, 1. Let me think about the x-coordinate. So at t equals 1.5, the ghoul is actually pretty much exactly halfway in between, just under halfway. And this does seem to be just under halfway. This also seems to be just under halfway. Okay, great. So I have now points that I'm willing to believe here. The final part of this question is just a little bit of computation to see which of these 2 points is actually farther from the origin. So it looks to me pretty intuitively clear that this one is going to be closer. In fact, I'm not even going to go through and actually run the distance formula. If you just compare the fact